Students, lesson number 13, chemical change and chemical bond. Under this lesson, we seen the first part of the lesson, that is chemical change and word equation, how to write. Under these two reactions we seen, that is the neutralization reaction also we seen, and then chemical reaction which is taking place in the living organisms, that is the photosynthesis and oxidation of the food, that reactions we had seen. Today we'll start the next part of the lesson, that is the man-made chemical changes. We bring about many chemical changes, okay, in a day-to-day life. We are continuously the changes are takes place, and under this the main chemical changes are taking place in our environment for our use in the everyday life. For example, coagulation of means formation of curd from the milk, okay, it is a chemical change. Now let us see some of them. So the chemical change that we saw in the first activity is used in the cold drink is called a cold drink is called soda lemon. It means that it is useful man-made chemical change. As you know that when the acidity takes place, then our grandparents, they are taking the lemon and the baking soda, okay, and then what happens, they are feeling better. So it is a which kind of useful type of man-made chemical change. Next, it is a combustion of fuels. As you know that the different vehicles are there, otherwise cooking gas is there. Otherwise, if you are seeing in older means olden time, the wood they are using as a fuel. So these all are the, from that we are getting the energy, from which wood, coal, petrol, cooking gas, these are all, okay, when we burn we are getting the energy from this. The common substance that burns in all these is called as a carbon. As you know that in wood carbon is present, coal carbon only, petrol, that is it is also contains the carbon, and the cooking gas also has the carbon as a main product. During the combustion process, carbon combines with oxygen in the air, okay. During the combustion of process, the carbon combines with the oxygen in the air, means this is the carbon which is present in the which wood, petrol, diesel or any petroleum substance, otherwise the cooking gas inside, and it reacts with the oxygen from the air and it forms the CO2, that is carbon dioxide gas, okay. So the common substance that burn in all these fuels is called as a carbon. During the combustion process, carbon combines with the oxygen in the air and the product carbon dioxide is formed. A common equation that can be written in all the combustion processes as follows. And which is that equation? Carbon which is present in the wood or any carbon substance fuel, it combines with the oxygen from the air and it forms the carbon dioxide. This is the word equation. And here the chemical equation, it is written as C for carbon, O for oxygen. Oxygen always it is present in the O2 molecular form, and when this combines with each other, what it forms the CO2, that is carbon dioxide gas. Combustion of fuel is a fast and irreversible chemical change. Just you know that it is a combustion, means when we take the burning stick near to it, what happens, it starts burning, okay. So it is a very fast and irreversible, means this is there is a no reversion, means we are not getting the it is not reversible process. Cleaning Shahabad tiles with the dilute hydrochloric acid. As you know that a chemical composition of Shahabadi tile is mainly calcium carbonate, CaCO3. CaCO3. Okay, it is the formula of the which, that is the Shahabadi tiles. During the cleaning with hydrochloric acid, the upper layer of tile react with hydrochloric acid. So this tile's upper layer is there, it reacts with the hydrochloric acid and three products are formed. So which are those three products? One of the is the calcium chloride, CaCl3, which being soluble in the water. This calcium chloride is soluble in the water, gets washed away with the water. The second product is the carbon dioxide. Okay, it is a gas, so what happens, mix into the air. So its bubbles mix with the mix up with the air. The third product, water mixes with the water, and the last product is the water. And the following equation can be written in the chemical change. So here it is the change. So calcium carbonate, when it reacts with the hydrochloric acid, HCl, it is not the balance reaction, it forms this calcium chloride, CaCl3 plus CO2 and plus H2O. So these are the products formed when we are cleaning the Shahabadi tiles with the hydrochloric acid. Okay. Now the next point is the softening of hard water. As you know that the bore's water, when the rain falls, at that time that rainy water falls on the ground and it seeps into the ground. After some time, what happens, whenever it is getting the way, from that way it is flowing inside the earth surface. Okay, and then what happens, whenever it is moving, the water soluble salts which are present in the soil, it get mixes into the water, and due to this what happens, the water, it becomes hard. Okay, its taste changes, its taste is brackish in taste and does not form lather with the soap. It is not forming the lather. This is because of hard water contains the chloride and sulfate salts of the calcium and the magnesium. It dissolved the state. Okay, and that's why what happens, this water is a hard. To soft the hard water, this is the hard water, and to soft it, the solution of washing soda, means washing powder, means which it is there, you are using urine powder, otherwise Tide, Nirma, Wheel. These powders are there that your mother is using, okay, for you cleaning the clothes. So why she is using, because of this washing soda, the water becomes what, water is hard, that whenever the different salts mix in, then it becomes harder. So washing soda, when we are adding to the water becomes soft, and this result in the chemical reaction to form the precipitate of insoluble which salt, that is a carbonate, salt of which calcium, means calcium carbonate, and the magnesium carbonate, as dissolved salt of calcium and magnesium go out form a precipitate of the carbonate salts. Okay, so it's precipitate form and it get what happen, go out. The water is softened and the following chemical reaction takes place in this process. As I told you, when the water is there, it moving inside the under the ground, at that time this calcium chloride and the sodium carbonate is there, it is mixes into the water, and because of it what happens, the water becomes hard, and calcium chloride is mixed into it, and sodium carbonate, that is Na2CO3, that is the formula of a washing soda, and when we add to it, it forms the calcium carbonate, is water soluble salt, and it is what happens, dissolve away with the into the water, and it go away, and sodium chloride, that is NaCl, water soluble salts are formed from this. And here it is a chemical reaction given, CaCl2 Na2CO3 means CaCl2 calcium chloride, water insoluble salt is there. When we add the sodium carbonate, that is the substance which that is washing soda, when we add to it, it forms the calcium carbonate, CaCO3, that is calcium carbonate, and the sodium chloride, that is the NaCl. Write the word equation and chemical equation for the changes taking place in the magnesium salt during the softening of the water. Okay, then that reaction we have to write for it. MgCl2, here instead of that, here magnesium chloride, sodium carbonate, here it forms the magnesium carbonate and the sodium magnesium carbonate, and here sodium chloride. So here when this reaction takes place with the magnesium, they are asking, so magnesium chloride MgCl2, it reacts with the Na2CO3, CO3, it forms the magnesium carbonate Mg. This is also reaction is not a balanced reaction, and plus it forms the NaCl. Okay, so this is the reaction we have to write for the magnesium chloride. Then the next part of the lesson is we saw that the composition of matter changes during chemical reaction. Means, so when the chemical reaction takes place, the matter's composition is changing and a new substance having the different properties are formed, and a new substance is formed whose properties are different from the original one. When this happens, some chemical bond in the reactants break and new substance called as a product are formed by the formation of new chemical bonds. So we saw that composition of matter changes during the chemical change and a new substance having the different properties are formed. When this happens, when some chemical bonds in the reactants break down. For example, if you see here the reactants, which are the reactants calcium chloride and the Na2CO3, means sodium carbonate. Here this calcium calcium breaks his bond with the chloride and combines, means it forms a new bond with the carbonate and it forms a calcium carbonate. Similarly, the chloride, which is separated from the calcium, it combines with the sodium, okay, which is the sodium, which is separated from the sodium carbonate, and NaCl is formed. Means in this chemical reaction, the old bonds are there, it breaks and the new bonds are formed. Then here what they told us, a new chemical bond. We have also seen in the chapter composition of matter that the number of chemical bonds are formed by one atom is its valency. Now let us see what is a chemical bond. So first point is the chemical bond. We have seen the relationship between the electronic configuration and valency of element in this chapter inside the atom. So we seen that how to find out its valency and what is the relation between the valency and electronic configuration. The noble gases do not form any chemical bond. Why? Because for example neon, krypton, xenon, okay, these are the inert gases. Their outer orbit is a complete, means its octave is complete, and that's why they are not forming any kind of chemical bond with any other substance. Then here what they told you, electron with incomplete electron octet or duplet. So here their octet or duplet is complete, that's why these noble gases are there, they are not react with any other substance. Then chemical bond. Reason for this is that the atom uses the valency electron during the formation of chemical bond. To form a chemical bond, what happens, we need to means here we need the valence electron, and these noble gases, they do not have the any kind of a means electron for the combination, and that's why what happens, they are not reacting with any other substance. Then here reason for this is that an atom uses valence electron during the formation of chemical bond. Moreover, forming chemical bond equal to the valencies of atom or electronic configuration of complete octave or the duplet. Okay. The next point is the ionic bond. Let us first see how the compound sodium chloride is formed. So for that we will study how it is formed. So here the atom of constituent element sodium and chloride, which are the atoms, sodium's atom and chlorine's atom. These atoms are there. They, first of all, these are the reactants. For this purpose, let us see electronic configuration of sodium and the chloride. As you know that the sodium's atomic number is 11. So in the first orbit, according to the rule 2n square, okay, 2n means first orbit 1 square and into, so 1 square is 1, 2 ones are 2, first orbit inside 2 electrons will go, 2 square 4, and second orbit if it is then 2, n's place you have to write the 2 square is the 8, 4 and 4 twos are 8. And then in third orbit how many electrons will enter? 1 enter. And chlorine atomic number is 70. According to the same rule, first orbit contains 2 electrons, second orbit contains 8 electrons, and third orbit contains the 7 electrons. Okay, then here we have seen that the correlation that the valency of sodium is, what is the valency of sodium? 1. And here chlorine's valency is also 1, because to complete the octave it is easy for the chlorine to take electron from the any other substance, and for sodium it is easy to donate the 1 electron from outermost orbit. We have seen that the correlation that the valency of sodium is 1 and it has 1 electron in the valence shell, and the valency of chlorine is also 1 because valence shell is short by 1 electron. Now to complete octave, both sodium and chlorine, what happens? They combine with, means they form a bond, they donate or share the electron. So actually in this they donate, and it once the one atom donate the electron, means sodium donate the electron and the chlorine receives the electron. So on loss of valence electron from M shell, the penultimate shell L of sodium atom becomes outermost shell. Okay, as you know that the shells are there. Shells are there. First shell is the K shell, the second shell is the L shell, and third shell is the M shell. So from that M shell, the sodium donates 1 electron. Okay, and now the sodium becomes outermost. L is the penultimate shell, and L is the L of sodium atom becomes outermost shell. So what happens after donating 1 electron from this? The outermost shell is the LM. Outermost shell is the, which is, that is the M shell. Now the L of the sodium atom becomes outermost shell, and it has 8 electrons in it. Okay, in L atom, L orbit, how many electrons are there? 8 electrons are there, and then it becomes stable. Now sodium attains an electron octet state and it becomes stable. However, the electron number becomes 10, hence the positive charge plus 11 on the sodium nucleus is imbalanced, and sodium Na plus cation is formed, and carrying the positive 1 charge is formed. On the other hand, valence shell of chlorine atom contains electron less than octave state, accepting 1 electron from the outside. The octave of chlorine is completed. However, the charge is charge balance is disturbed, and due to the addition of 1 electron in the neutral chlorine atom, and this result in the formation of Cl minus, carrying a net negative charge -1. Now whatever I read it, the meaning of it is that, in short I will tell you, as you know that atomic number of sodium is 11. So just now I told you the 1 electron who is donating, sodium is donating. Now its electronic configuration is 2,8. Now chlorine's actually electronic configuration, how it was? 2, 8 and 7. So after taking electron from the sodium, what is its electronic configuration? 2, 8, 8. Okay. Now sodium has how many electrons on it? 10 electrons. And how many protons are there? As you know that number of protons are same like the atomic number. So 11 protons are there. And the sodium has how many electrons? 10 electrons. So here the protons are positively charged. So protons are more. That's why here we have to write sodium plus, because it shows that one proton is more than the electron in the, after donating 1 electron by the sodium, and then sodium it forms the sodium's cation. and that electron who is donated by the sodium, who takes chlorine, it takes. Now how many electrons it has? 2, 8, 8. Means 8 to the 16, 17, 18 electrons. And how many protons are there in the chlorine? 17 protons are there, and 18 electrons are there. And here the one electron is more in the chlorine, and that's why what happens, it gets the chlorine anion. And here the exchange of the electron is shown. The outermost orbit inside sodium's outermost orbit, one electron who donates, sodium donates, and it is what happens, enter into the chlorine's outermost orbit. And what happens, if the octave of both sodium and chloride is completed, and it becomes stable, and this is nothing but our common salt. Is the meaning of this whatever paragraph just now I read it, okay, its meaning is given in the figure. All of you understood whatever I said that? So today you are going to complete this, understand this, read the lesson, and the next part of the lesson we will see in our next lecture. So today we will stop here only. Okay, thank you and have a good day.